This time on Jairus of All, I redesigned the hidden blade from Assassin's Creed and make it the best one ever. The hidden blade from Assassin's Creed is one of the most recognized video game weapons of all time, which isn't surprising because Assassin's Creed has sold over 172 million copies, making it one of the top video game franchises in history. And I highly doubt Assassin's Creed would be that successful if the hidden blades were not in the game. Because what you can do in the game with these blades is awesome. It is without a doubt the ultimate stealth weapon. A huge number of people have already made physical versions of this concealed automatic knife. There's even files on Thingiverse that you can download right now and print your own functional prop. The first one I ever saw was Colin Furze. He made a fantastic, all-metal, fully functioning version. All of these use the same basic system. It's called double-acting out-the-front knife, and it's been around for a long time. And this is how that system works. A string attached to your hand wraps around a spring-loaded wheel with a pin in it. When you pull on the string, it turns the wheel, which can only move halfway around. When that pin moves, it pushes on a piece inside of the knife that puts tension on a spring and then releases a catch. The spring pushes the knife out of the front where it locks in place, and when the pin finishes its movement, all of the pieces move back to their original position inside of the knife. When you release the string, the wheel wraps it back up, but the pin does not move because it's like a ratchet. So when you pull on the string again, the pin moves the rest of the way around the circle and makes the pieces move the opposite direction, causing the exact same thing to happen again, just backwards, which makes the knife blade pull back inside. But is this the best way to make hidden blades? Is it the system to use? No, it's not. The blade is being flicked out, not pushed to extension, which means if something gets in its way, it'll stop and fall back in. Or best case scenario, give something a little prick, and it's called Assassin's Creed, not Pricker's Creed. That also means your timing has to be perfect, because if you're a little bit off, the blade's just gonna fall back in, which changes you from a really stealthy assassin into a very awkward assassin.
Ha!
Hi. Why'd you touch me? This is awkward.
And then there's that muscle spasm style hand movement you have to do to get the blade in and out. Not stealthy. On a scale of I saw that to stealth, it's everyone's looking. In the game, there are times where you put your hand right up against the enemy, and the blade is so powerful, it does the full extension and retraction without you having to move, which means you never even see the blade. Very stealthy. So my hidden blade needs to have a lot more force for the extension and the retraction, and the movement to activate it needs to be a lot more subtle. There are a lot of options to consider for how I'm going to accomplish this, but I've settled on liquid air controlled by lightning. A container of liquid gas is going to give me a lot of force, and I'll be able to accurately manage it with electronics. Also, I think I can make this system pretty quiet. Imagining how something could be made and actually making it are two wildly different things. This project seems very simple. It's just a sliding knife. Even when Colin Furze built his mechanical system, he used a lot of tools that most people, including me, don't use or have access to. You can end up spending a huge amount of time trying to make parts by hand with simple tools like files, but you'd still have to spend the time practicing to develop the skill level necessary to make those parts actually work. Remember the Manus blades? But there's a solution for projects like this, and it doesn't include spending tens of thousands of dollars or months and months of time. And it's the only reason I'm doing this project now, because I already created my design in the imaginary computery world of digitalia, and I sent that design to Protolabs, and they hooked me up with these amazing parts. And everyone has access to this service, including you, and Protolabs makes it very easy. All I had to do was upload my parts, and it kicked back an analysis to let me know if it matched with the CNC process. So I updated my model to match the analysis and hit go. And it was so fast and easy, it was hard to even believe that I was done. But that is Protolabs' goal. They want to make the process very simple and quick so that you can spend your time working on all the other stuff while they do the CNC machining, 3D printing, injection molding, and sheet metal fabrication. Protolabs would have tapped the holes in the housing, but I wanted to do it by hand because they're blind holes, and I need to use thread taps with different tapers to get the threads the whole way in. Plus the outer walls are very thin, which makes the housing small, but it makes this process delicate. Bolts are not going to go all the way through, and that makes this part look sleek and futuristic. Obviously, I'm taking some liberties with the aesthetic of my hidden blade because there are so many versions in the games that it seemed fitting that mine should be a unique design. I want it to be modern and built for utility and stealth. I need to polish the part where the blade slides for the seals, but I don't want to polish the outside of this half because that's the mating surface. So I need to find something to transfer that to the tape so that I can cut out the part that needs to be polished. This acrylic paint should stay wet long enough that I can get a transfer, and it should be easy to take off. Let's try one side and see how it does. Squish, squish. Hey, look at that. Do the other side. Squish again. Yes, very nice. I'm going to start with 220 grit, and hopefully that's not too aggressive, and then I'm going to work my way up through the grits until this is mirror polished, finished, hopefully. Well, that was fun. This decided to remove my masking for me, so I guess with a little bit of polishing that's left to do, that's fine. Yeah, I'm gonna try a different polishing method. The knife blade is going to be getting seals in these grooves right here, which is why I sanded this so smooth so that when it's sliding back and forth, it doesn't sand those seals off. Since I'm already sanding, I might as well sand the outside to make those machine details really look good. That looks pretty cool being sanded with 220 grit, but I bet it'd look better if I sanded it with 400. Man, that looks really good. But should I polish it? Well, you know what they say, can't go kicking possums without your shoes on. Time for polishing. Now that is a shiny piece of aluminum. Time to switch gears from making things look pretty to making things work pretty. And I got these micro fittings to attach the airlines to this. And even though they're small, they're still too big for it to fit on my arm properly. So I'm gonna try to make my own from scratch. I could use a drill to make these parts. I've done it in the past, but I recently got a mini metal lathe from my friend Kirby, who was the short fused leatherneck on YouTube and used to use this lathe to make awesome stuff a long time ago. But since his passing, it has come to me. That way it can continue to be used in a way that he would approve of, making awesome stuff for YouTube. And because of this lathe, I can make these parts far quicker and more accurate than if I were to use a drill. And because they're brass and the tubing is copper, I can solder them all together to make really extra tiny little fittings that make this thing fit against my arm exactly like it should. And to make sure these don't receive any stress from the copper lines that are attached to them, I use some scrap aluminum to make this little hold down bracket that will keep those in place and keep my fittings in one piece. My blade needs seals just like any pneumatic piston, but because everything is completely custom, no one makes seals that fit the parts that I made, so I need to do it. So I 3D printed molds, and my idea is that if I use mold making rubber and pour it into those molds, whenever I pop it out, it will hopefully work as a rubber seal for the custom shapes that I have. I made very tiny variations in the sizes of these seals to see if slightly bigger or smaller works better. So now, just to see which size actually works, if it slides, this might actually work. High pressure air comes through this tube into the back and moves the blade forward. When high pressure air comes through this tube into the front, it moves the blade backward. Seal in the front seals the blade, but as it comes the whole way to the back, it loses its seal as the tip comes back in and it's hidden, but that doesn't matter. The momentum will carry it the rest of the way to the back, where I plan to put in a magnet to keep it there. This is copper spray gasket. I put a few layers on this to seal the top and bottom housings together because I didn't design in a tolerance for a gasket to be on here, but it needs to be sealed, so let's hope this does the trick. Want your name on my work table and digital files for this project? Join my Patreon. My Patreon supporters make videos like this possible and get cool perks like these. There's always a point in my projects where a lot of work is finally gonna get tested to see if the work was worth it or not. You know, from designing this and then having Protolabs make the parts to putting in all the finishing work to get this ready to actually do it. There's a lot on the line right now, so it might not seem like it, but it's always a really big deal whenever I go to test this stuff for the first time, because it's the difference between, okay, move forward in the project, and, oh great, now I have another week's worth of work to do. It's hooked up to the air compressor at 20 PSI for the first test so that I can see if it moves and hopefully find out if there's any major leaks. 3, 2, 1. Holy cow, that's too much pressure. It doesn't leak at all. The only leak I'm getting is from the valve inside of this piece of junk. Okay, we're gonna turn the pressure down now. This front seal I have less faith in. It could push out back here on this side. But before I go making another part, we're gonna try 5 PSI. So hopefully it goes a little slower. 3, 2, 1. Oh, it's blowing that seal out. Okay, I'll hold that seal in place. That was so perfect. Wonderful. Okay, we're gonna go back out, make it extend. That's beautiful. Yeah, that's not loud at all. That's amazing. I could not be more pleased with this right now though. It's beautiful, it's going to fit wonderfully, and it works great. See you next time. Hey Bryce, what's the difference between an assassin and a master assassin?
What?
Master's got 2.
Okay.